Okay, and good morning to everyone. And that was the Grateful Dead, Uncle John's Band. And we're finishing up our second week of the semester already. And one of the things I've tried to point out to people as they've come in the door, we are focused on homework today, answering questions in that, and you may be asked to turn in one of the chapters today. We've had time to go through it for 2 weeks. You'll be able to make some corrections as we talk about the homework problems. So that's on the agenda today. I'd like to answer questions about the lab, and I'd like to answer questions about the calculator, but try to bring closure to these 2 chapters. And on the board, I have some information that's going to relate to box plots, the more complete version that we're going to reference as we'll do in a lab in the future. Before I do that, I'd like to go to the document cam. Here's a question for you based on what I did yesterday. I referenced in the Student Study Guide pie charts, bar charts, histograms with the intent to bring it to your attention. Could you now answer this question? The answer to it is in the study guide, but it would not be a bad short answer question, first part of the exam. It reads, if you took 12 countries from World Factbook 2008 and 3 were from Africa, how many degrees should you have in a slice of the pie representing Africa? Write down your answer briefly. It takes just a moment to write down your answer if you know it. I don't want it verbalized yet. You can just write down a number for me. If you write down the correct number, then you have a handle on pie charts. If you don't have an idea in the world of how to get that value, then there's a message there. Go to the Student Study Guide and figure it out. Now, we made a comment yesterday, the editorial referring to the fact that spreadsheets, such as Excel and Lotus 123 at one point, and there are a number of spreadsheets, there are a lot of what we call freeware on the systems where you aren't using Microsoft and the Office suite that will do spreadsheet analysis. Bringing up the idea that there's an effort to sort of disassociate from Microsoft. And of course the biggest one came out yesterday of recent time. What was it? The Google browser was released yesterday as an alternative to Internet Explorer, which is going into version 8 at some point. So this effort to create software that will do what Microsoft has done with Excel is starting to incorporate something other than Excel. So now your answer should have been 90 degrees. Reason? The relative frequency for Africa, you have 12 countries. 3 were from Africa. That's 3 over 12. That's 1/4. 1/4 of 360 degrees in a circle gives you 90 degrees. So you have what is referenced as the first quadrant. Or think of the hour hand on the 3, the minute hand on the 12, and that would define on a clock, such as we have in here, the non-digital version, the analog version, you would have a circle, and again, if the minute hand is on the 12, the hour hand on the 3, that would define the first quadrant, and that's where you would put 25% of your data in that region. Now, how would you handle the problem if 4 countries had been in Africa out of the 12? How many degrees now? You should be able to answer that given what I just gave you as information. 4 out of 12 is what fraction? 1/3. There's 360 degrees in a circle. So you'd have 1/3 of 360, so your answer would be 120. Now that's a little more difficult to do with what we talk about as a compass and a straight edge, which was a classic construction in geometry going back into Greek mathematics with Euclid. So the question is, how do you get 90 plus 30 to make 120? Because that would require that you trisect an angle. That was not something that could be done with a compass and a straight edge. Now, I realize that many of you, because of the way that you fulfilled your mathematical background, may not have had a course in geometry. If you take the 2 algebra courses, that you would require as prerequisites to this course, you would have seen some geometry. But if you had taken a formal geometry course or a course that involved trigonometry, you might have come across a thing called a protractor. And a protractor was a way of getting an angle that could not be constructed with a compass and a straight edge. So you could actually locate 120 degrees as part of the circle and get the sector, which we are calling a slice, of the circle to create the pie chart. It is not unreasonable to expect a problem on the test where you would be asked to do either a pie chart or bar chart and have to do it in a reasonable fashion. So I would expect you to estimate roughly where a third of 90 is. So if I were doing a pie chart, let me go to the board behind me and some free space I have here, Jennifer. I had the R right at the end. But if I do that and look at a circle, and I look at the center of that circle, then the first thing we typically do is bring a radius out at a horizontal position and argue that that is the baseline for that first part. Then I come up here with a right angle, which I can construct, and I think of partitioning this out so I have a diameter. And of course, this would be half your data down here. This would be a fourth of your data up here. And then the question is, how do you estimate another 30 degrees out of that 90? And so if you have this in a test situation, I would expect you to make some effort to roughly break that arc into 3 equal pieces. And it's sort of a trial process, and I came pretty close. So these would be the breaks on the arc, and since I want this to come out roughly to 30 degrees, this would be my 120 degrees for 4 countries out of 12. And then the question is, how do I reference what should be in there? So oftentimes, this is done through color, as done in your lab, and then we have a legend. Or you could simply say that this is Africa, and this represents 33%. And that works pretty well as long as you have big enough slices that you can do what? Write something in. But if I have one country out of 12 representing OC, you don't have much space there. And so we typically have arrows that designate that small region, and again, it's very difficult to estimate exactly where that would be, but let's say this is to represent roughly. Okay, so if we have 1/12, 12 into 360 is 1/12. Okay, so 1/12 is going to be 30 degrees. Agreed? So I have that smaller than I need. I was thinking it would be smaller, so let me go ahead. I should now replicate what I had up here for 30, so I guess I could do this here. I was thinking it was going to be a smaller piece of the pie, but there would be my 1/12, and let's say that's OC, but you can see where it's starting to get a bit crowded. So we might do something like this with an arrow and say OC out here and then give the percent, which is going to be 1/12. Okay, so 1/3 is 33%, 1/6 is about 16+%, and so 1/12 is about 8%. So we'd have about 8% here, and so we do something like that. You have to, when you do these by hand, do some clever kinds of things. You don't typically, when you do them by hand, indicate different colors. You leave the whistles and bells for a spreadsheet. But I expect you to understand how those are created. And so again, they are not done in your text. It's covered in the student study guide, and that's why I took time to bring that to your attention yesterday. Enough said about pie charts. While we're talking about the student study guide, I want to slide over here now, Jennifer, to the left, and I have some formulas. These formulas are referencing what we're going to call the complete box plot, which is not the simple version that's in your text. And I will expect you to do box plots on the exam using what we call fences. So the UOF that you see here is upper-outer fence. So the I refers to an inner, and the L refers to lower. And I'm giving you a reference. This is on page 5-4 of your lab manual. So you open up your lab manual now to lab number 5, page 4. And here are your formulas. They, again, are not in your text. As a reviewer of David Moore's text for the last 3 editions, I and a number of other reviewers have encouraged more detail in the box plots. David Moore has finally, and one of the problems you have for a box plot in which he talks about 1.5 times the IQR, establishing whether a point should be considered a possible outlier, addresses that, but not as well as I'd like. So again, these are 4 formulas that are on page 5-4 in your lab manual. Look at your lab manual for a moment and see what's there. And you will be needing those formulas for the exam. So the box plots that you did or are doing, perhaps in present tense, out of the first 2 chapters should, in some of your efforts, include the fence calculations so that you can determine if you have either suspicious or extreme points. I'll go into that in more detail. While we're at it, turn to page 5-2 of that same lab. In 5-2, upper left-hand side of 5-2, you find Chebyshev's statement. It's not in your text, but it is in your lab manual, and I will remind you that on the exam, you're responsible for what is in lecture, what is in the lab manual, what is in the study guide, and what is in your text. All of that is fair game. So if I take time to reference something during lecture out of the student study guide or bring it to your attention in the lab manual, you need to put an asterisk or something there and say, hey, this is serious enough that I better take some time to address it. Now, I do want to come back to this idea of a box plot for a moment. But right now, I have one more thing on my agenda, and that is to remind you where the homework assignment is. So I'm going to come back to the computer here as I press a button. And as we come back now to the document cam, homework assignments for the 4th edition. That's what you're doing. This is on the home page. It's the home page for the video-based class, but it's also set up for you. So I click on that, and as I do so, I get the comment here, homework assignments reference the 4th edition. Problems with links provide a full solution so you can check your work, and answers to odd-numbered problems are found in the solution key. And this page, unfortunately, you'll note, is now not available. That's because the publisher got angry.
No, it actually is.
It is now?
Take off the asterisk and
If I take off the asterisk and the address, and that will now work, let's see. Well, that was not by intent, because technically I'm not supposed to show you this. That's why I put the asterisk there. And I won't show it on public television because I was asked not to. So I didn't hear your comment. So going ahead, let's come back to what you were shown. This is what's shown on the page as I have it. And so let's leave it at that. You can check the back of your book for the solution. It's the same thing that's in the back of your text. Now I'm going to scroll down. I don't know if I got myself out of the hot water there or not, but
I think the solutions are from the previous edition.
okay, thank you. Thank you.
So you might match up.
Okay, that makes me feel better. These are the homework assignments. I'm going to just zoom in there. And the links that we were referencing, okay, in the first part, notice, do not include anything in the first chapter. I didn't feel that the problems there were difficult enough that they merited providing solutions for you. But in Chapter 2, we have 2 problems linked, and if you click on where those problems are, you go to a PDF file in which the solution has been carried through. So there is some opportunity to check your work. Now, I give you typically 10 problems per chapter. That's not as many as some of my colleagues do. Some of my colleagues double that. Okay, and to that extent, I demand more on the labs. They demand more on the homework problems. I think the labs are a critical aspect of the course because they provide you with an opportunity to do many research papers. And so the focus is intended. So with that said, we're going to take some time to look at some of your questions and homework before I look at the complete box plot. So what is your pleasure? We'll start with Chapter 1. And you'll notice the problems will be restricted to what we're seeing on the screen, 4, 6, 8. Let's go back to that if you would please, Jennifer. 4, 6, 8, then 11, 25, 29, 34, 35, 37, and 41. And again, in homework, as we come off there, I expect when you draw anything, you use a straight edge. You do not freehand it. So you use straight edges for histograms, bar charts, pie charts. Use a half silver dollar, half dollar, something to make a reasonable circle. And when you are doing your calculations in Chapter 2, I expect formula, substitution, and answer. And if you're doing things like finding the standard deviation, where you have to do the conceptual formula, then I want to see what you've carried through. So Q&A time from Chapter 1. Q&A from 1. Which one? 41. Okay, so we're going to go to problem 141. It's a little bit like a stem plot. The first one refers to the chapter, and then the problem would be the leaf. So we go to 141. Now, this is a problem involving a time plot. And the idea is to put two broken line graphs, is what I'm going to call them, on the same graph so that you can compare General Motors and Toyota. And of course, what's the major issue here from current events? Who was number one? General Motors. Who has taken over number one? Toyota. This morning, 4:30 a.m., Wall Street Journal reports Toyota has a 9.7 decrease in sales, but General Motors has a 27% decrease in sales. No, 20%, and Ford was 27. So General Motors 20, Ford 27, and Toyota 9.7. And those, of course, tend to be the big three right now. And the problem in this case is to look at something besides sales. And it's why the sales are what they are and what is being addressed here in this 41st problem. Anybody? What's a word that would summarize what you're looking at here? Have you read the problem? If not, take a look at the thing and then make a judgment. You don't have to have done it to read it. Okay, reliability. I want another word that is very much a part of statistics. Now, reliability and redundancy would be a phrase or two phrases that we would use in IT for basic computer systems. Give me another word that is very much the practical application of statistics. Maybe a two-word phrase. Okay, quality control does not jump into your mind. Or quality. And the argument has been, that Toyota has done what? Done a better job with that than has Detroit in general. And so the satisfaction. J.D. Powers, they rank the different automobiles, satisfaction, number of complaints, etc. And so the argument is Toyota's done better than GM, and GM has lost sales as such. And of course, Toyota morphed from small trucks to compete with the monsters And of course, they found that they have the same problem Detroit has. That it's interesting. Drive over to Alfred Matthews on McHenry. Take a look at their car lot. 6 months ago, you saw truck after truck after truck. Today, try to find a truck. If you're shopping for a truck, you may not have your selection there. You may have to wait for it because they have gone to what? Fuel-efficient cars that everybody is concerned about. So this problem is very much to the point. The figures at 2004 to 2008, the question comes, if you look at your data and you plot these points and join the points with the broken line graph, could you extrapolate what you think would be 2008 data? That is what time series analysis is about. Now, does anybody have that plotted? You do? Okay. Could I see your plot, please? Thank you. Very nicely done. Looks good. Okay, let me just show you what this should look like, and I appreciate the quality of the presentation. There it is. Now, the one thing that I really appreciate is that you have the GM line identified, but you biased definitely against Toyota. So if you're going to publish this in a paper, somebody's going to say, well, I wonder who the other company is. They'd have to look at your title, which is Toyota versus GM problems. So just a hint, equal time, or you would be accused of bias. Now, looking at it further, very interesting truncation for the next question I'm going to ask, but I like what you've done. Now, clearly, you don't have anything under 100, right, to worry about. That was the lowest. So, broken line here, very nicely illustrated, and it goes from 100 to roughly 190, it looks like. But what would you anticipate for Toyota if it's going down and we go 4 more years? That might just continue that trend, and now let's say it's where my eraser is. What value is that? You can't get it from this truncated vertical axis. Now, it might be naive on my part to argue that it's going to do what? Continue to go down, because what happened from 2002 to 2003? It went back up. But then it dropped down below where it was in 2002. Extrapolating to 2008, a bit dicey. But if I make that effort, you've complicated it by the fact you had this broken vertical axis as we come back to it. That's called truncation. I asked you yesterday, what might you do with a bar chart to mislead? Truncating the vertical axis in exactly the same way. Okay? So if I were to, instead of doing a dot, do a vertical line, then the difference as I come back to this, and think of a vertical line coming from here and comparing it to here, looks like what? Maybe an 8-to-1 ratio? Where if I were to actually bring this down to 0, it's not going to seem that great. So that truncation with a bar chart is possible. What do you can observe relative to what's asked here? And the question was, what are the most important conclusions you can draw from your graph? Okay, back to the graph. What conclusions? Toyota has less problems. They will probably sell better. And indeed they have. But what do you also notice in terms of complaints? Go ahead. Overall problems have gone down in both companies. That is, as we come off there, the dilemma for Detroit. Now, to put things in perspective relative to statistics, the key, there are 2 names that you should associate with quality control, and you should have an awareness of that. One is Shewhart. Okay, that's S-H-E-W-H-A-R-T, I believe. I can look that up a moment on Google. But Shewhart was with the Bell Labs out of Stanford University about World War II time, arguing that we should have quality control. We didn't worry about it. Couldn't sell it. post-World War II production. You have to understand, you could not buy a new car in 1945 or 44. The pennies were not made out of copper in 43. They were zinc. Don't see them very often these days because they're in collector's items. Collectors sort of hang on to those. And in 1948, post-World War II, you bought a car if you could get one. It's sort of like trying to get a Prius right now. Hard to get. Any fuel-efficient car, you may have trouble getting off the lot. You may have to order it. I can remember my dad getting a 1948 Ford that was not a good car. You'd call it a lemon these days. And his attitude was, I'll get another new one next time. Then there wasn't a lemon law. There was no quality control. The argument was if an engine was going down the conveyor line and it fell off, they get a forklift, put it back in the line, and let it go on through. And if you ask, well, aren't you concerned? No, somebody will buy it. Okay? And that was the state of affairs for the Detroit until the first oil crisis. And that's when the Honda Civic, that skateboard that was a car, when it first came out, I mean, it was small. You talk about small cars. Skateboard is a good mental image. Until that time, Detroit ignored quality control, but we went into post-World War II recovery. This is all part of statistics. If you take a course in quality control, this is what you read about. Because in 1947, 48, we went into Japan to some degree out of guilt. Because what have we done? Folks, there's some things you just damn well better know. And this is one of them. What did we do to Japan at the end of World War II? That's how it ended. Bombed them. Well, we did that to Germany, too. Dresden still. There's some rather bad memories about the firebombing of Dresden, Germany. But what did we do when we bombed Japan? We just drop a little old bomb? Okay, it was an atomic bomb. Mushroom clouds. Right? Did we do it once? No. We did it twice, as if one was not a big enough lesson. Oppenheimer? Robert Oppenheimer? Los Alamos? Oh, Lord, folks. You need to read. Okay, he was who brought together the work of Einstein. Einstein, we recognize? I feel like I'm giving a history lesson this morning. At any rate, guilt complex, United States. You dropped two bombs. Harry S. Truman was responsible for making the call post-FDR. And we said to Japan, we'll help you rebuild. But in the classic American fashion, personified in Frank Sinatra's song, you'll do it my way. And so we imposed upon Japan quality control. And the second name, besides Shewart, is Deming. Edward Deming, who was involved with the Census Bureau, was involved in Japan in modern quality control, and folks, the rest is history. In 1950, if you wanted to buy a quality camera, who did you buy it from? Which country? Germany. 2000, buy a quality camera. Who do you look to first? Japan. Canon. Nikon. Not Leica or Zeiss. Okay, you go with Japanese. Their quality, better. Who do you look for in electronics? 1950, United States. 2000, Japan. Okay? Quality control. And Japan did it well with cars. Now, coming back to the graph. This says that the Toyota in the year 1998 with substantially fewer complaints than GM. GM took notice and both companies improved. But Japan still holds what? The continued edge. Now, perception is very important. And if you perceive of what kind of car you should buy, most people, in thinking of quality or mileage, think either BMW or a Japanese car. And the perception, even though Detroit's improved, is still there, and Detroit's battling that seriously. Now, is there any question how you create this graph? Juan, you asked the question. Is there any question about how you plot these ordered pairs as I come back to the document cam? So I make the time the horizontal axis. The vertical axis is going to be the number of complaints. And what often is done here to identify these better is to make the two line graphs or broken line graphs different colors. Or make one of them a solid line and make the other what? Dashed or something. But this is done very, very well at the quality I would expect. And again, the title was up here, Toyota versus GM Problems. Exceedingly well done, exactly what I would expect to see. Any further question in the problem? And that allowed me to give the part of the lecture I wanted to give on quality control, and I've said about as much there other than, if you're doing quality control, it's this simple. You know the empirical rule. You know how to get the average, and you know how to go to 2 standard deviations on each side. If your production stays within the 95% range with the empirical rule, so you have a leeway in production. You're producing something for a car. You have tolerances that are allowed. If you keep those within your 95% range, then you have 5% defective rate. And that's pretty acceptable. You don't say defective these days. You just say does not meet specifications. But it's still good. It just doesn't meet the specifications of the person I am doing the outsourcing for. Okay? How do you make the product with fewer defectives? I'll come back to that word. You decrease the standard deviation. How do you decrease standard deviation? Engineering. Better equipment. Better employee commitment to quality. That's the toughie. Okay? To make the commitment. Now, Juan, any further question on that problem? Any other questions in chapter 1? 11. Can you give me a page number, please? This is problem 11 somewhere in chapter 1. Thank you. Page 21. Okay, this is a problem about glucose levels. People with diabetes. Monitor that. Now, the goal to maintain between 90 and 130. That's like quality control. I want to maintain it between those two values. The following are fasting plasma glucose levels for 18 diabetics enrolled in a diabetes control class 5 months after the end of the class. So that's the setting. This is a research problem. It says make a stem plot. Okay? You have 3-digit pieces of data, correct? They go from something in the 90s to something as high as 359, correct? What is it now? 78 to 359. Okay, 18 pieces of data. How many intervals would I like? 18 pieces of data. Powers of 2. Give me an argument. 4 would be nice, correct? That's your goal. Okay, now you have stems in the hundreds. So if you had a 0, hundreds, 100, 200, and 300, you would have what? 4. Your 78 is going to have to be the 0 hundreds. And the 359 would be the 300s. So I would run, as we go to the board again, Jennifer, a vertical line, and then I'd run a 0, 1, 2, and 3 for my stems. And I said I'd like 4 intervals, correct? Am I going to get 4 intervals? Yes. Now, my leafs are going to have to be 2 digits, or I do what? We round. So round off to the nearest 10. So that's 359 is going to round off to what? 360, so I put a 6 here for that. And then how do I tell the reader that that's 360? I have a legend. 3 vertical line 6 equals 360. Is that enough? The rest is just fill in the blanks. We okay? Any other question on 11? Anybody do 11? What does it look like? Can you tell me if it's bell-shaped or not? Sean, just hold up your paper so I can see. The question is, wouldn't I split the stems? No. I know they do, but I wouldn't. Okay, we're having a question Sean will share with me. Why would you not want to split the stems? Powers of 2 rule. Now, what happens if you get too many intervals? You're likely to lose a perception of what the shape of the distribution looks like. You get noise. If you don't have enough intervals, you tend to get 1 bar, maybe 2 bars, and you lose information. Now, if David Moore has done his homework on this, and you have to understand that many authors, including myself, when we write materials, doing problems is not the fun part. Writing about statistics is fun. Creating problem sets, So you hire graduate students to help you provide solutions for problem sets. And sometimes you even ask for other people to contribute problems, and David Moore's had people contribute for him. Now, Sean ends up with this as his stem plot, and it does a pretty decent job, right? But what does it suggest at the moment that might not be valid in terms of what we're seeing? This comes up with a bell, and this stops down and comes back up again, correct? Now, if I were just to combine the 1s and the 2s and the 3s, I think you're going to see just a skewed curve. Now, what you've done by splitting the stems is create a sense of what? A possible outlier here that may not exist. You're creating a possible sense of bimodality, 2 curves, 2 populations that may not exist. With stat graphics, you don't get choices. I put this into stat graphics. There is a rubric, if you will, a criterion that's programmed into it to decide the number of intervals, and you get what you get. You can't change it. When you do it longhand, by hand, you could sit here and just go with the 4 intervals I have on the board. If you're going to do the split stem plot, one thing you're going to be tempted to do as we come back here is you look at this 3 down here, and some people want to omit that because there was nothing there. You must show that stem, even though there's no leaf involved, so that you see the distance between these 2 values, suggesting that the 360 might be what? An outlier. Which brings me to the whole question of the box plot and the criterion we're going to use to determine if we have an outlier. Any other questions in problem 11? Thank you, Sean. Any other questions? Chapter 1. Okay, I will collect chapter 1. I will collect it at the end. I don't want to mess up noise right now, but at the end I will ask for chapter 1 to be turned in to me so I can look at it over the weekend. I do want to talk about chapter 2, but I do need to see a little bit more about box plots, or at least present more on it. I want to do that now, and if I have time, I'll entertain questions from Chapter 2. So let's go back to the board behind me, Jennifer. That's where I have the fences, and that's this portion right here. Now you know what fences are. On fences, this is like having, there are a couple of different illustrations. Think of a moat around a castle. So you have the inner bank of the moat and the outer bank of the moat. Anybody in the moat is suspicious. You assume they aren't just swimming to exercise and do laps. And anybody outside the moat that shouldn't be outside the castle grounds has escaped. Replace castle with prison. And that's extreme. So if you're inside the moat, that's where you should be. That's a little bit of the idea. So the inner fences give you the inner banks, the outer fences, the outer banks. Anything between the inner and the outer, suspicious. Anything beyond the outers, outer bank, outer fences, considered extreme. We will use in a box plot a little box to represent a suspicious point. We will use a little asterisk or star to represent an extreme point. The whiskers, this is the crucial point. The whiskers only go to the last data point inside the inner fences. You do not show the fences on your box plot. So with that in mind, if I were to look at the 18 pieces of data we just had in problem 11, and I want to determine if 360 is indeed a point that is extreme, what I could do, and I'm going to try to combine something here because of time. I'm going to go back to Stat Graphics for a moment. Let me bring this back to here. I'm going to minimize this as long as the computer will cooperate quickly. I'm going to double-click on Stat Graphics. It is coming up right now. And I'm going to get my spreadsheet, and there is what you should be seeing. I'm just going to enter this data. So at this point, Sean, you're going to help me, I hope. I want you to read off the data. I'll enter it as you read it, starting with the first row. Problem 11, page 21. I think the first one's 141, correct? So I'll enter that, and I'm coming down now. Second data point, please. 21. What is it? No, I'm talking about first row, 158. Okay, 112. 112, 153. Wait until I get it entered. Next. 134. Next. 95. Next. 96. Next. 78. Next. 148. Next. 172. Next. I need to bring this down so you can see it. So let me bring this down to 172. Next. 200. Next. 271. Next. 103. Next. 172. Next. 359. That's the one I rounded off to 360. Next. 145. I've got one more to go. Two more. 147 and 255. Thank you. Now that's my data. I'm going to bring this up again to the top because I need to identify the column. So at this point, just for convenience, I'm going to left-click at the top. Notice I'm coming down now, and I'm doing more than you realize. I'm showing you how to enter data in Stat Graphics. I'm going to modify the column, and I have column 1. I want to rename that, and so for the lack of creativity, I'm going to call it data. That was not real clever, but nonetheless does what I want. So I want to describe that. So I'm going to go ahead. I'm doing numeric data, one variable analysis, and there's only one choice. And if I can get the right spot, data. So double click on that, do an OK, and bingo, there is my box plot. Okay, now what I wanted to illustrate is illustrated very nicely there. That pink is not doing anything for me. Give me a moment to change the color there. And I'm going to do what we did yesterday. I'm just going to take a nice yellow color, do OK, apply, and then OK. And now, as I look at this, what you're seeing here with that red plus, that is your mean marker. It is to the right of the median line. Therefore, your conclusion. Coming off there, folks. We talked about this in the last couple of days. If the mean is to the right of the median, what about bias? Which side is it? It's to the right. The skewing is to the right. If I did a histogram, I'd expect to see something skewed to the right. Let me come off this for a moment. I'm going to go up to, as I come back to the computer, okay, if I wanted to do a graphical analysis quickly, graphics options, third icon, and when I do that and look at my choices, I would want a frequency histogram. So I do that, do an OK, and although I'm not real pleased with that, do you see the skewing? Number of intervals, a little bit overkill. I've got 5, I want 4, I need to tweak that, but it is skewed to the right, and then we don't have much of that right side showing. So, your skewing is to the right. Coming back to my box plot. The argument, since the mean marker is to the right of the median, and this time, please memorize it. This is the third time I've talked about this. If the median is to the mean, I'll restate it. If the mean is larger than the median, if the mean is to the right of the median, your skewing is on the right side. Let's go back and look at the box plot. Notice the mean marker is to the right of the median line, which is the center line here, not quite centered. These are called the whiskers, correct? I suggested to you that if we have a suspicious point, we will represent it with a box. This suggests there are 2 suspicious points. So one of them is that 360 that was on Sean's stem plot. The other would be the next highest data value, which was what in that list? Well, we don't need to really look at the list. What I can do, and watch this, hot links, and I'm not talking about Polish sausage. I click there on that little box. Now I'm going to go back up, and I'm going to go a little bit more to the right, and I'm going to go to where you see window, and I come down to what is going to be called untitled. That's the name of my file because I haven't saved it. But I bring that up, and what you see is a highlight. By the way, that's blue on my screen. But if I look at that, there's the 271, and that's considered a suspicious point. Now, we haven't looked at what we would call the first and third quartile. That would mean we would have to do what? Go ahead and sort the data, correct? So, if I come back and look at this, and what I'm going to do is come up to the top here, and I've clicked on data. I'm going to right-click, and when I do that, and come down on this pop-up, I come down to a sort file. I'm going to sort it. And when I do, I'm going to ask, I think, to put this in descending order and do an OK. Now, the reason for doing that is I can now quickly see where my quartiles are, correct? I have 18 pieces of data. Agreed? That's an even amount of data. So my median is going to be at the 9.5 position. So I want between 9 and 10. Coming back to the file. Here is 8. Slide down just a little bit more. There's 9 and 10. Between 147 and 145. What's the number between them? 146. Okay? So as I come to the board, I have x tilde is equal to 146. I'd like Q3 and Q1. I'm using the computer to help me. So to get, thank you, okay, Q3, Q1, and x tilde. Now we'll come back to the computer, Jennifer. And on this, if I have 9 values at the top, and I want the median of those 9 values, it would be the 5th value, correct? So what is Q3? 172. Okay, coming back to the computer. I want now the bottom 9. So as I come to the bottom 9, I need to be at what value for Q1? I want the middle of those 9 values that go from where? That was the top 9. These are the bottom 9. So I want to go to the which value if I just count down? 1, 2, 3, 4, 5. There are 4 above and 4 below. So what is my Q1? I heard one of you say 112. Very good. So if I have these 2 values, what's my IQR? Well, first, by formula, we just had that on the left side of the board. It's Q3 minus Q1. So you have Q3 minus Q1. That's your formula. Substitution, 172 minus 112, and that is equal to 60. Done. Oh, I love 60. Because I'm going to take 1.5 times 60 when I get my fences, and that's 90. And 3 times 60 is 180, even without a calculator. Huh? Okay, now what we're going to do is we're going to bounce back and forth, Jennifer, between the left and the right side. I'd like camera 2 where I am, camera 1 on the left side with the fences, please. Got it. Okay, going there. Upper outer fence, Q3 was what? The other camera? Okay, that's 172. Plus, we said 3 times 60 is 180. So I add 182, 172, and get what? 352. Wow. Practice arithmetic. 352. Do I have anything higher than 352? Yes, it is what? 36 or 359? So I would disagree with what Stat Graphics has done here. They're evidently using a slightly different approach to finding the Q1 and Q3. Now I'm using the approach used in your text, which is you do not include the median once you've done this. We'll have to go back and see what Q3 and Q1 is. Either I made a mistake in Q3, Q1, or 360 is a what? 359 is an extreme point and should be challenged. Okay, I need the upper inner fence. That's going to be my Q3, 172 plus 60, right? And what does that give me? No. Oh, hold it. Yes, thank you. I was doing just IQR. I should have done 1.5. Thank you, Sean. And so it would be what? 90 plus 172. 262 in our head? If I'm blocking your view, look at a monitor. Okay, did I have a value? Let's see, the second value that we had indicated was what? The next one, next highest to 359 was what? 271. 271 is what? Beyond the inner fence, inside the outer fence, so that's suspicious. Now, I want to come back to the computer before I go anywhere else. Going back up here at the top, I have 359. I said that's extreme. 271 is what? Suspicious. What's my next data point? 255. So my whisker goes to the 255, not the 262. The whisker doesn't go to the fence. It goes to that 255, which was the last data point inside that upper inner fence. That is critical. There's no way you see these fences on your box plot. Now I need to finish out this. Okay, what was Q1? We said 112. And so I'm going to subtract 90. And so I get what? 22. Do I have any reading that low? No, I think my lowest was what, 70 you said, or 78? So I don't have anything below that lower inner fence. No suspicious, no extreme points on the low end. While I'm at this, we take 112 and I subtract 180 and I get a negative number, correct? Which is a fence is valid. It's just, in terms of my data, it makes no sense. But that's negative what? 68. You've got your fences calculated. Okay, now back to the computer. Now I'm going to come back up to the top, and I want to bring back my analysis I did. So I'm going to go to Windows, and I had an analysis here. I called it one variable analysis. That's at the very bottom. So I click on that, and there is what I have with my one variable analysis. And I'm going to double click on that for a moment and come back, and I'm going to go to this analysis toolbar. Remember, the third one was graphical options. The second one is tabular options. So I'm going to click there, and I'm going to do this fast. I get a pop-up. This is mix and match. I have summary statistics. So if I look at my summary statistics, and that was what I had down here in the lower left-hand corner, I'm going to double-click on that, and notice I have quartiles given to me. Lower quartile is what? Q1. Upper quartile, Q3. Do those match? Does my IQR match? Yes. And this program did not do what it should because my upper fence was to be what? As we look at this on the board, we said our upper outer fence was at 352. Did I screw up a calculation here? I don't believe I did, and so that 359 should have been what instead of a box? When I had the box plot, it should have been what? An asterisk. So unless I'm missing something here, I want to come back and look at this, and maybe, oh, I am in error. I criticized when I shouldn't have. That's a box with a plus in it. That's the best they can do for an asterisk. That was my extreme point, and I can't bring that any tighter than what you're seeing, but that isn't a box. I didn't look closely enough. That's a box with a little plus in it. That's their star. Okay, that's how you do box plots by hand. In my case, with the help of a computer, because I'm down to 90 seconds before I have to close out. So we're going back to the great...